Okay, AP Biology, let's talk a little bit about cladograms. Cladograms are basically diagrams that demonstrate proposed relationships between groups of organisms. They're not necessarily an evolutionary tree. They don't include all of the organisms within a group or an evolutionary line. It's just a comparison of a group of organisms that are chosen by the scientists, right? So you could choose any group of organisms and then create a cladogram to see how they're related. So what you're going to do to create a cladogram is you would look at morphological, structural comparisons as well as molecular comparisons. So you might look at amino acid sequences or DNA sequences. You might look at physical features. Cladograms come in many different shapes and sizes. They all have the basic premise together. The closer two organisms are in a cladogram, the more closely related they are, and the more common ancestor they share. So let's talk about the pieces and parts of the cladogram. So first of all, there's the clade or clade. These are all clades. Each group of organisms in your comparison are considered clades. So the tuna is one of the clades. A node is a branching point. So this is your relationship, and this is comparing traits. So these organisms are related, and of course at some point there's been a branch in the evolutionary timescale, right? So this is where the lamprey would have branched off. They do not have jaws. They're jawless fishes. So they cannot continue on the lineage with the rest of these organisms. So a node is a branching point, and it indicates a common ancestor. So a common ancestor is just an ancestor that's shared between more than one group of organisms. So like the turtle and the leopard both share this common ancestor here. All of these clades, the lamprey, the tuna, the salamander, the turtle, the leopard, they share a common ancestor here, right? They all branch from this point. So that's a common ancestor that they have together. The outgroup is the most distant related out of the group. It has the least number of characteristics the same. So like the lancelet does not have a vertebral column. So that differentiates it from all the other organisms in this particular group. The trait that they all share is called an ancestral trait. So all of these organisms got their vertebral column from a common ancestor. Each of them have new traits that have caused branches in their lineage. Those new traits are considered derived traits. They weren't present before. So the jaws were derived from the vertebral column. The hair were derived from the amniotic egg. So everything below the derived trait shares the traits below it. Everything above the derived trait will include that derived trait. So it's a more recent trait that they got from a more recent common ancestor. Okay? Of these two, the ones that are most closely related would be the turtle and the leopard. They share the most derived traits. They have the jaws, the four walking legs, the amniotic egg. So that makes them the most closely related. They have the most common traits together. For the most part, you'll just be analyzing cladograms that are already made, but on occasion you may have to build your own cladogram. So how would you do that? So take your group of organisms. Here I have frog, rodent, lizard, gorilla, fish, and bird. And you want to identify traits that you can see in groups of those, like subgroups. So like I know that the rodent and the gorilla both have hair. So that's a good one to include. I know a number of these have eggs. So that's a good one to include. So you want to look at traits that you can find that are common between them, and also traits that are different between them. So continue listing traits until you have one trait common to all groups. So what is common to all of these groups? They all have vertebrae. And then enough differences that allow you to sort through the rest of your organisms. So here we've made a checklist identifying the traits that we have for each organism, right? So now compare the number of shared organisms, or compare the number of traits that are shared between the organisms. So I can see the frog only has 2 of these. That's not very many. The fish only has 1, and all the rest of them have 4. So this is going to help me identify the fish is the least related, and then the frog. Now I got to try to figure out how to sort out the others that have just 4. So I'm going to put the fish closest to what's called the root, which is closest to the ancestral trait. For me, it's easiest to rearrange my table so that I can see the common traits lined up. So here I've rearranged it. I can see all of these organisms have vertebrae. And then the next most common trait is the 4 limbs. So I know that's going to be my first derived trait. And then the next most common was amniotic egg. So that's the next derived trait. And then eggshells, 2 of them have eggshells. So they're going to be a group that is branching together. And 2 of them have hair and fur. So those 2 will be a group that branch together as well. So now I'm ready to draw my tree, taking the same chart that I started with. This will be the order that I put my organisms from least to most common. Okay, so draw my line, and we said the fish was going to be the least common. It only had 1 trait. The frog had 2 traits. Then I got to figure out, am I going to go lizard, bird, gorilla, rodent? They all have the amniotic egg, right? So let's use my amniotic egg next. And from there, the eggshells will branch, and then hair and fur came at a different time, okay? So here I can see lizards and birds are closely related. Gorilla and rodent are closely related. They all share common ancestors with the fish. So I'm ready to add my branching points. So I put a branching point every time a new trait appeared. Okay, so add your traits. My ancestral trait was the vertebrae. The next most common trait was the 4 limbs. So they all had 4 limbs except for the fish. So the fish does not have this. From here on, every organism has 4 limbs. The next most common was the amniotic egg. From here on, everybody has an amniotic egg, right? So this is a derived trait that is common to those organisms that come after. I branched my bird and lizard, and if I made these in reverse, that would be acceptable as well. This isn't a timeline. It's just showing relationships, right? So if I put the bird and the lizard and flip-flopped them, that would be fine too. And then I added in my hair and fur, and that is my derived trait. And again, the gorilla and the rodent both have this trait, so they branched together. And again, I could flip-flop them if I wanted. It's not a timeline, it's an evolutionary relationship. So either way, it would show the same relationship. It would show that these 2 branched from the main line, and they both have hair or fur. Okay? So, be able to find close relationships, further relationships, derived traits, ancestral traits, the number of clades, the number of nodes, the number of branching points, those sorts of things. Okay? So I hope that was helpful.